Hello there, this is Group 2 from UPM Space Reaching Group Presentation for subject SKAB3712 Geotechnique 2. Our group will be presenting our project paper on foundation design. The presentation will be started by me as the leader of the group with some introduction and also background of our project paper. And then the rest of the presentation will be done by our group member in according to their designated task. So let's start with our presentation. The paperwork and the presentation will be submitted on the 30th of June 2022 as required by our lecturer. Under this design project, we were basically given 3 tasks to do, which is the first one is design a proposal for a proposed interchange bridge or abutment. Number 2, we will need and required to plot the soil profile of the proposed project site, of course with reference to the given data. And number 3, we will need to design the appropriate foundation and abutment for this project. These are our group members, starting from me, Jerome Roni, and then followed by Miss Jesselyn Naklawi, and then Madam Jesen Anaganya, Mr. Reynold Ramnestis, and Madam Jocelyn Anak Medol. To get a feeling of a real-life project, we have given our project paper title, which is a construction of a new abutment and new road connecting from existing road from Robert Homestay to the existing road of the Borneo Tribal Village in Kampong Apa, the district of Bau, Sarawak. However, this title is only created for the purpose of this project paper, academically saying it does not represent any real project in the said location, but the location itself, even the names of Robert Homestay, Borneo Tribal Village, and Kampong Apa Reserve do exist, and we can search it on Google Map. So for the purpose of this project paper, academically, we just created this project title. As mentioned in the project title, the purpose of this project is to make a new connecting road from an existing road very close to Robert Homestay to another existing road going to the Borneo Tribal Village. But along the way there will be a small river which is around 15 to 20 meter width, and thus the task given to our group is to do soil investigation and then continue with design of abutment and also the foundation. This is where the proposed project for the new connecting road and of course together with the connecting bridge to be built. So after studies were done, not only on the soil condition but also on the vicinity around the river itself, which is as mentioned before around 15 to 20 meter width, the best option is to build a new bridge, and from there our team continue to make design for a new bridge together with the foundation and all the abutment design. From this map we will get some idea where to build a bridge and also how will the road be built. These are picture taken on road level at the Borneo Tribal Village road heading towards Borneo Tribal Village actually, and there are 2 lines there. The 2 lines is the proposed connecting road, the orientation of the road, and this is another road level picture taken just to give us an idea where it's heading, and of course in this picture it's heading towards the Borneo Tribal Village. And that concludes my presentation for the introduction and sub background of our project site. The next presentation will be on the soil profiling. Thank you.
Hi, I'm Jesselyn Lewi from group number 2. I will present the soil profile at pH number 2 to to pH number 4. So as we can see in the figure above, the ground level of the soil surrounding the pH number 2 and pH number 4 mostly consists of silt with sand and gravel. Silty soil can be smooth to the touch and retains water longer because of its smaller particles. However, because of its tendency to retain moisture, it is cold and drains poorly. This type of soil is light, moist, and have high fertility rates, so that is really close on the ground level. The silt soil also of medium-sized particles that are well drained and can hold moisture very well. The next layer is 5 meter to 18 meter below the ground level consists coarse sand at pH number 2 and sandy clay under the layer near pH number 4. Clay is made up of tiny particles, so it stores water well. But because of its tight grasp on water, it expands greatly when moist and shrinks significantly when dry. When clay is moist, it is very liable and can easily be moved and manipulated. These extreme changes put a great deal of pressure on foundation, causing them to move up and down, and eventually crack, making clay a poor soil for support. After that, from 18 meter to 30.3 meter is hard layer, which consists of greenish, gray, spot white sandy silt at pH number 2, while at pH number 4, there is slightly silty fine sand with gravelly clay, sand to silty fine coarse sand. Sand or gravel has the largest particles of the different soil type. It is dry and gritty to the touch and does not hold moisture because of the large opening, but drains easily. When compacted and moist, it holds together fairly well, and if compacted, they smack. For good soil to support a foundation because of their non-water retaining properties. However, when moist, the particle will lose their friction and can be washed away, which can leave gaps beneath the foundation. This layer is heavy soil that benefits from high nutrients. So, in conclusion, this type of soil is silty sand, which has heavy particles. Due to the presence of heavy particles, the particles are loosely packed, leaving large space for air. Since there is a lot of space for the air to get filled, they are unable to hold water and the water gets easily drained. The type of soil is more suitable for the growth of cotton as the soil can hold plenty of air. That's all from me. Thank you.
Hello everyone, my name is Jesena Ganya. Today I'm gonna present about bridge foundation. For everyone information, bridge is a structure which cover any gap or any obstacle to give a passage through it. Generally, bridge carry a road or railway across a natural or artificial obstacle such as a river, canal, or another railway or another road. What is foundation? A foundation is the part constructed under the pier or abutment and over the underlying soil or rock. The loads transmitted by the foundation to the underlying soil must not cause soil shear failure or damaging settlement of the superstructure. The foundations of a bridge are particularly critical because they must support the entire weight of the bridge and the traffic loads that it will carry. The purpose of foundation. Purpose of foundation is to distribute the load of bridge over a large bearing area and provide stability of bridge against settlement and tilting. It is provided sufficiently deep so that it is not affected by the scoring. Types of foundations. The type of foundations is designed when subsoil data of bridge site is obtained. The different types of foundations for bridge are given following: shallow foundation, spade foundation, and rough foundation. For deep foundation, it is pile and well foundation. Shallow foundation. A shallow foundation is sometimes defined as one whose depth is smaller than its width. A shallow foundation can be laid using open excavation by allowing natural slopes on all sides. This is normally convenient above the water table and is practicable up to a depth of about 5 meters. Shallow foundation transfer the load to the ground by bearing at the bottom of the foundation. Deep foundation. A deep foundation is defined as one whose depth is larger than its width. Deep foundations cannot be laid using open excavation. Deep foundation transfer the load to the ground, partly by end bearing at the bottom of the foundation and partly by skin friction with the soil around foundation along its embedment in the soil. Piles are preferred over wells as they are more economical than wells. Pile foundation. Use of pile foundation has still recently not been a popular choice for bridge. For road bridge, this has been used mostly as timber pile for temporary bridge and where subjected to lighter loads. RC pile both precast and cast in situ as well as larger diameter board piles below bed level are becoming popular. A minimum diameter of 120 mm for river bridge and 750 mm for the other is preferred. As you can see, this is the diagram of the foundation. This is the real image for clear views of the foundation. Well foundation. Well foundation are constructed on dry ground in suitable form and then sunk into the ground to the desired level by grabbing the soil through dredge holes provided, surrounded by the soil masonry. The diagram shows the well foundation for your viewing. Well foundation. The component of well foundation. First, well cup. The structure of well at the bottom is tapered to end in a steel cutting edge which facilitates cutting through soil for sinking of well. This tapering portion being thin, it has to be straightened suitably to take up the heavy loading. This portion is called well cup. Second, staining. The structure in the form of wells surrounding the dredge hole is known as staining. Third, bottom plug. The concrete placed at the bottom to form the base of foundation for distributing the load to soil below. It's known as bottom plug. Fourth, top plug. The concrete placed at the top at finishing level to transmit the load of structure to the well staining is known as top plug. The advantages for well foundation. This provides a solid and massive foundation for heavy loads and high horizontal thrust transmitted by the moving loads. Second, this has a larger cross-sectional area and hence, the total foundation bearing capacity is much larger than piles. Third, wells can be taken through soil having boulders, logs of wood, and such type of obstruction without causing damage to the structure. The fourth advantage is the machinery is the staining of well is good in dry condition and hence quality of machinery or concrete can be assured. Fifth, the well provides good grip when taken sufficiently deep and hence more suited to the river bed subjected to heavy scour. Hence, the choice is mostly in favor of well foundation where large spans requiring deep foundation has to be provided. Block foundation. It is a form of shallow foundation used for small bridges in locations where there is a good foundation strata at shallow depth, but is overlain by very soft layer of soil and high water table, making open excavation difficult due to small quantum of work. For site selection, ideal characteristics of bridge site. First, suitable, unyielding, non-erodible material for foundation should be present at short depth for piers or abutments. Second, the bearing strata should be free from the tendency to slip or slide or sink under load. 3. The stream at bridge sites should be well defined, as narrow as possible. Number 4. There should be straight reach of stream at bridge site. Number 5. The site should have firm, permanent, straight and high banks. Number 6. The flow of water at its stream at bridge should be steady. Number 7. It should be feasible to have straight approach road and square alignment. Number 8. There should be minimum obstruction of water ways so as to have minimum efflux. Number 9. There should be no need for costly river training works in vicinity of bridge site. Number 10. At bridge site, it should be possible to provide secure and economical approaches. Number 11. In order to have minimum foundation cost, the bridge site should be such that no excessive work is carried out inside water. Number 12. In order to achieve economy, there should be easy availability of labor, transport facilities, construction material in vicinity of bridge site. Number 13. There should be no confluence of large tributaries in the vicinity of bridge site. In case of curves alignment, the bridge should not be on the curve but preferably on the tangent, since otherwise there is more probability of accidents. Finally, the bridge sites should be such that adequate vertical height and waterway is available underneath the bridge. That's all for my slide today. Thank you.
Hello, my name is Jocelyn Anamuntoy and I'm going to present about the abutment design for our group project. The title for the design is the proposed the interchange bridge, and the subject is to design of the cantilever type of abutment. From the screen we can see the general information that need to be used, and the design for abutment A1 shall be adapted for abutment A2. This is the properties that need to be considered to design the abutment. We have for that also, which is it means the depth scope we have 0.6715 meter for the calculation, but under referring to the clause 713.3.1.1 of RIC 78/2000, maximum depth of score for design of foundation of abutment is equal to 1.4 meter. This is a drawing. Next, the calculation for the dead lot. And this is the general item that need to be considered. And we have the determination of depth of facility, which is determined from the IS 2009-11, class B 1.2, appendix B, and the soil type is silt. For the fixed headed pile, we have 5.7 meter. Next is the dead lot, the calculating forces at the base CG of abutment shaft, and the lot and the moment to the dead lot on the abutment are tabulated as below. This is the calculation for the vertical lot and for the moment. The subtotal can be seen as on the screen. So for the resultant forces under LWL, we have 17.99. For the parquet base at point A, this is the calculation and the subtotal for the vertical lot and the moment. This is the calculation for the under HFL condition and also under the LWL condition. For the resultant forces under the HFL is equal to negative 175.256, while for the forces under the LWL we have negative 179.803. Next is the earth pressure. So this is the soil properties that need to be considered. So for the coefficient of active pressure, we have 0.279 for the horizontal. And then the calculation for the horizontal force and moment at base due to earth pressure, we have the intensity pressure at AR, at the HFL, and the founding level. And this is the earth pressure diagram. Next is the calculation for the horizontal force for the abutment base, the moment for the abutment shaft and the pile cap, and also the intensity pressure at RL. This is the drawing. And we have the horizontal force, the calculation for the moment for the abutment shaft and the base of pile cap. Next is the dynamic increment of earth pressure. The assessment of earth pressure shall be calculated as per IRC 6/2010. This is the flexibility factor that we need to consider. So for the horizontal seismic coefficient is 0.144, and the vertical seismic coefficient we have 0.072. Next is to increase the in-earth pressure under seismic condition. Under the HFL condition calculation, for the abutment shaft and the pile cap, horizontal force at the abutment shaft and the pile cap, and then for under LWL condition calculation. Next is the seismic forces. This is the calculating forces at top of pile cap, and we're using the seismic coefficient for the horizontal, which is equal to 0.144. This is the calculation for the seismic force and the moment, the total for the without superstructure for the HFL condition and LWL condition. Also for the base of the pile cap, total for the lot and the moment. Next is the live load surcharge, which is equivalent to 1.2 meter, and the head of the earth field shall be considered in the design. So the increase in surcharge pressure under seismic condition. We have the increase of surcharge forces, which is 15.13, moment at the abutment shaft, and lastly the moment at the base of pile cap. For the next part, it will be presented by my fellow group member. Thank you.
Hi, my name is Randall Mercedes. I'm one of the presenter of this apartment design. Now I'll continue with part of the design. Go to the next slide. Here is the calculation for restraining force at bearing. We're also looking for the live load. So the live load and the class of loading also. So next we also check on the maximum reaction condition of 1 train, 2 train, so next we also check loading for the class 70R. This is the diagram showing the loading. Then here is the longitudinal force for 1 train. Okay, next step is we summarize the force on the base of abutment shaft. Okay, from this table we can see that showing the loading for the live load for class A, class 70R, earth pressure, live load surcharge, restraint force at bearing, and seismic. Next, we check on the load combination. Okay. We will check normal condition according to the few cases. So we will calculate all these load combination until the case 8 cases. Then we also check on the seismic condition. Also, we consider until 8 cases. Next step is a summary of force on the bracket base. We will check on loading for the dead load, live load, earth pressure, live load surcharge, the same force at bearing, and also this is the same as the summary for the base of the abutment shaft system. We also check on the load combination again from the normal condition according to or with 8 cases. Okay, and also the seismic condition, we also check again the combination. Based on these cases, we check until the 16 cases. Then we go to the design of the dirt wall. Dirt wall is designed for earth pressure at the base of earth pressure. Then we will check on the binding and also the shear moment, shear force. After that, we also check the design for the side wall. And again, we do the checking for the bending moment and also shear checking. Okay, that's all for my presentation. Thank you.